Good afternoon, everyone. Thank you so much for joining us. My name is Katie, and I'm with the NOAA Central Library, and I will be your host today. We are super excited to be partnering once again with the Weather Program Office for this short series. It's going to be focused on their social science projects that were funded under the FY18 Hurricane Supplemental. A few logistical notes. If you are attending, you are muted. So all attendees are muted. Your questions and any chat that you want to send to me needs to go through those questions or chat panels. We will be holding questions until the end of the presentation. Additionally, this is being recorded. So if you have to step away for some reason, you can find the whole recording on the library's YouTube channel. I will share that in the chat shortly. Also, since we are recording, anything that you put question-wise in the chat will also be recorded and shared with the speakers and the hosts of this after the fact, just so you are aware. And with that, I'm going to turn it over to Gina, who is going to introduce our speakers today.
Thank you so much, and thank you for that lovely introduction. As Katie mentioned, the Weather Research and Forecast Innovation Act of 2017 requires NOAA to prioritize research that improves forecasts and warnings for our mission, right? The protection of life, property, and the enhancement of the national economy. Specifically, Section 104 of the Weather Act, as well as the Bipartisan Budget Act of 2018, otherwise known as the Disaster Supplemental, provided NOAA with a wonderfully unique opportunity to integrate the social, behavioral, and economic sciences into NOAA's tropical products, information, and services, as well as incorporate risk communication research into the design and communication of its products. The Weather Program Office worked side by side, truly in tandem with the National Weather Service to fund 4 projects to reach these goals. Today's webinar will kick off a 4-part series to highlight this important work, and we hope that all of you listening in today will join us again at noon on Wednesday for the next few weeks. These projects in today's webinar would not be possible without a huge team of people, and as such, I'd like to publicly thank the NOAA Central Library for hosting their webinars, the National Weather Service, including Jennifer Sprague-Hildebrand, Jessica Schauer, Robbie Berg, and the entire Tropical Roadmap team, as well as Mickey Olson and Cassie Williams from the Weather Program Office for their just amazing commitment to social science research to operations. It's just been an incredible journey to work all together. And of course, I'd like to thank our academic partners involved in all of these projects and their commitment to work together with us towards these shared weather enterprise goals. With that, we are thrilled and very excited to introduce our speakers today, Dr. Joe Ripberger and Jinan Allan from the University of Oklahoma Center for Risk and Crisis Management, whose project was funder under this supplemental funding. The project examines how end users, such as forecasters, emergency managers, and the public interpret probabilistic tropical cyclone information. And so today, Dr. Ripberger and Jinan will present their project and their early results to date. I know they'll have more, but the early results. With that, Joe and Jinan, the floor is yours.
All right. Well, thank you so much, Katie, for having us today, and thank you, Gina, for the introduction. I am here, and Jinan is here as well. But I wanted to say that this project is really a collaboration between multiple scientists here at the National Institute for Risk and Resilience. And so in addition to Jinan and I, Dr. Kahika Gupta, Carol Silva, Hank Jenkins-Smith, and Ed Coakley have been instrumental in all of the research that we're going to talk about today. I have all of our email addresses at the end of the presentation. And so if you have any questions for us that we're unable to answer today, or if you want to follow up with us to hear more about what we have found subsequent to this presentation, please shoot us an email and we're more than happy to talk with you about what it is that we are finding. As Gina said, our presentation really today focuses on something called numeracy and the extent to which numeracy affects the way that forecasters, partners, and members of the public understand and use some of the products that folks might see during a tropical cyclone event. And so the primary motivation behind our project is that weather service scientists and partners are developing new models and data assimilation techniques to produce probability information that is meant to help forecasters better communicate uncertainty to partners and members of the public. And if you take a look on the right-hand side of my slide here, you'll see just a few examples of the probabilistic information that people might see during a tropical cyclone event. Up here, for example, you see a map that indicates wind speed probabilities. Here you see a map that indicates the probability of precipitation or the probability of a specific amount of precipitation at different points throughout the United States. And then over here on the right, you see a map that indicates the probability of a given amount of storm surge at different locations. And what these products have in common is that all of them, in some way or another, use probability information to communicate uncertainty about what is likely to happen, where, and when. And from a social scientist perspective, we believe that the propagation of this probabilistic information is a positive development in the weather enterprise, but that there are many barriers to effective comprehension and communication of probability information. Some of those barriers relate to the products themselves. For example, there are inconsistencies in the way in which different products communicate probability information. Some projects use fractions, other projects use percentages or percentiles. Some give probabilities at specific point locations. Others give probabilities for aerial locations, such as within 25 miles of a given point. And those inconsistencies can make it difficult for folks to understand a given product if they're perhaps used to looking at a different kind of product, right? But then in addition to these product-specific inconsistencies or barriers, there are also cognitive differences in how forecasters, partners, and members of the public interpret and use probabilities when making decisions, right? And this project, our objective is to accelerate effective communication of probability information in weather forecasts and warnings by systematically identifying some of these barriers to comprehension and communication of probability information, and then more importantly, developing a set of recommendations to help us overcome these barriers. And today I'm going to talk specifically about two research questions that we have been focusing on to date. The first research question is, what is the distribution of numeracy among forecasters, partners, and members of the public? And when I say numeracy, what I mean is the ability to interpret and use numbers when making decisions. And then second, I'm going to talk about, does numeracy impact comprehension of probability information in weather forecasts, right? And then to the extent that numeracy does influence interpretation of probability information in forecasts, how can we make probability information more accessible to people with different levels of numeracy? To answer these questions, as part of the broader project, we did a set of 4 studies that map comprehension and communication of probabilistic information from forecasters at NCEP centers to forecasters in weather forecast offices, emergency managers, and then down to members of the public. And on the right-hand side, this just gives a very brief overview of what the risk communication structure looks like during a tropical cyclone event. Forecasters at the Hurricane Center, for example, or the Weather Prediction Center, or the Storm Prediction Center, they issue some kind of forecast, and in some cases is given to WFO forecasters. WFO forecasters in some cases take that information and communicate it with emergency managers, and then on down to members of the public. And what we wanted to understand is how folks in each of these groups understand and use probability information when making decisions. But before I talk a little bit about how we understand those things, I wanted to just acknowledge that what we don't study as part of this particular study is how broadcast meteorologists make sense of probability information and how they use it when communicating with members of the public. And obviously that's an important omission because many people receive information from broadcast meteorologists during tropical cyclone events. And so we hope to look at broadcast meteorologists as a separate group in future research. But for now, and for today, I'm going to focus primarily on WFO forecasters, emergency managers, and members of the public. And we went about studying numeracy in these groups by doing a series of surveys. And the surveys we did were basically the exact same. They included the same set of questions for forecasters, emergency managers, and members of the public. Approximately 297 forecasters completed the survey in WFO offices across the country. Only 67 emergency managers completed the survey, and that's partially because the survey went out right near the beginning of COVID-19. And so what we're doing right now is we're getting ready to re-implement that survey in hopes of increasing that sample size a little bit so that we're a little bit more confident in the generalizability of our results. And then the public survey, we actually did effectively two surveys. One survey of 1,000 people from across the United States, and then a separate survey of 2,000 people who specifically live in coastal areas that are most at risk of experiencing tropical cyclone events. So in whole, 3,000 members of the public took part in our survey. And on the survey, we included multiple questions that measured what we call general numeracy, weather numeracy, and comprehension of weather forecast products that include probability information. To measure general numeracy, we used 7 different questions that looked something like the question you see here. Imagine that we flip a fair coin 1,000 times. What is your best guess about how many times the coin would come up heads and 1,000 flips? Basically ask people that question, and then we kept track of how many people got that question right? And then in addition to general numeracy, we were interested in weather-specific numeracy. So your ability to interpret probability within the context of a weather forecast. So one item of that 7-question set was, if a forecast indicates a 1 in 10 chance that storm surge will exceed 9 to 11 feet at a given location, what is the probability or percent chance that this location will get less than or equal to 9 to 11 foot of storm surge? And again, we were tracking the number of people, the number of forecasters, emergency managers, and members of the public that were able to get each of these 7 questions correct. And then after asking people these general numeracy and weather numeracy questions, we measured comprehension of weather forecast products that include probability information. And specifically, we looked at the 3 products that I showed you guys before. We looked at this precipitation product, the wind speed product, as well as the storm surge product. We gave people an example of what that product looks like, and then gave them a hypothetical location, in this case, location A. And then we said, which of the following statements best describes the rainfall forecast for location A? And you can see here that people could have said, well, there's a 90% chance that location A will get more than or equal to 4 inches, less than or equal to 4 inches, or approximately 4 inches. Or they could have said, I'm not sure. In this case, the correct answer is this less than, right? And so we took those survey questions and began by asking ourselves, what is the distribution of general numeracy among forecasters, partners, and members of the public? And what you see here are density plots that show the distribution of general numeracy across the entire range of each of these 2 groups. So for example, this density plot here shows you the probability density, or effectively the proportion of forecasters that had a numeracy score of 0 versus forecasters that had a numeracy score of 7, right? and the same thing with respect to emergency managers and members of the public, right? And if you look at these density plots, you would observe two things. First, there is a large gap in mean numeracy between forecasters and members of the public, right? Average numeracy for forecasters is right here, right? Whereas average numeracy for members of the public is down here, right? And not only that, there is a significant number of forecasters that have the highest levels of numeracy, right? Whereas there is a significant number of members of the public that have the lowest levels of numeracy on our scale, right? So we see this large gap, and then we see that emergency managers straddle that gap, right? They're in the middle of forecasters and members of the public, but at least with respect to general numeracy, they look more like members of the public than they do WFO forecasters, right? So we see these main trends, but we also see considerable variation within all three groups, right? Especially forecasters, right? You can see that on average, forecasters have these relatively high levels of numeracy, but there are some forecasters that have lower levels of numeracy and some forecasters that have even higher levels of numeracy, right? And it's the same thing with respect to emergency managers. You know, the modal numeracy score for emergency managers is 1, but there is this other group of emergency managers that have considerably higher levels of numeracy, right? And you can begin to imagine how this complicates the process of developing products that include probability information. You have to decide which of these emergency managers are you communicating with on a given day. The managers that are up here who look more like forecasters, or the emergency managers who are down here who look more like members of the public, right? So that is the distribution of general numeracy. But then when we look at the distribution of weather numeracy, we see a slightly different story. First and foremost, of course, we see that forecasters, despite having varied levels of general numeracy, have very high levels of weather numeracy, right? When it comes to the weather, they are able to interpret and use probabilities almost the highest, almost off the charts, right? Whereas you see that members of the public are quite a bit lower in their levels of weather numeracy. And again, we see that emergency managers are there in the middle. But what we also see, though, with respect to variation, is that almost all forecasters are up here towards the top, but emergency managers and members of the public are even more spread out, or are even more varied in their levels of weather numeracy than they are in their levels of general numeracy. Which again, as I alluded to before, this might complicate the process of developing products for these groups because their numeracy scores are really all over the place, right? But as I said at the onset, what we really want to do in this project is not just understand the distribution of general numeracy and weather numeracy. We want to understand that distribution and how that distribution might affect comprehension of probability information and forecasts. And so what we did, as I said before, is we gave people these 3 different products and then asked them or looked at the number of products that people correctly interpreted, right? So this is an example of that wind speed probability product. And you can see here that 92% of forecasters correctly interpreted this product, whereas only 61% and 43% of emergency managers and members of the public were able to correctly interpret the forecast for location A, right? And if you look at the storm surge probability product, you see a somewhat similar pattern. Emergency managers, 94% of them correctly interpreted the product. 82% of emergency managers, so considerably higher there for emergency managers, and then a little bit less than 50% of members of the public were able to correctly interpret the probability information in this product. And so across all 3 products, what we observe, of course, is that WFO forecasters interpret most of the products correctly, right? So these products were developed by the Hurricane Center in the Weather Prediction Center, and forecasters in local offices across the country, in most cases, correctly interpret those products, right? But there is significantly more variation in how emergency managers and members of the public interpret those products. So for example, here is that quantitative precipitation forecast that includes probability information. And we can see here that 85% of our forecasters were able to correctly interpret this information, whereas only 21% of emergency managers and 28% of members of the public were able to incorrectly interpret this risk, right? And so we see quite a bit of variation in terms of, the proportion of people who correctly interpret the product, and then B, to the extent that they incorrectly interpret the product, their interpretations in some cases are all over the place. So for example, some emergency managers interpret this product to indicate that there's going to be approximately 4 inches of rain, which is not the intention of the product, whereas 32% of members of the public think that this product indicates the probability that this area will get more than or equal to 4 inches of rain, when of course the correct answer is that it will get less than that amount of rain, right? And so what we wanted to know, as I said, is whether or not general numeracy and weather numeracy impact people's ability to correctly interpret these products, right? And what I'm showing you guys here are 2 plots where along the bottom you see 0, 1, 2, 3, 4. That is someone's numeracy score, both for general numeracy and weather numeracy. And then along the side, this is the number of items that they were able to get correct when given those different products. And what we can see is, yes, that both types of numeracy, both general numeracy and weather numeracy, strongly impact a participant's ability to correctly interpret a given product. And what I don't show here is that for context, we looked at the relationship between numeracy and product comprehension in comparison to some of the other things that might affect product comprehension, such as socioeconomic characteristics like age, education, income. And effectively what we found is that numeracy is by far and away the most significant predictor of whether or not someone is able to understand one of the products that we use on this survey. And beyond that, we also found that weather numeracy in particular has a more pronounced impact than general numeracy when we look at the 2 items together. Right, so now I've hopefully shown you that there is significant distribution in the population of general numeracy, significant variation in weather numeracy, and this variation leads to different levels of comprehension of probability information and forecasts. But we wanted to go a little bit further by asking ourselves, does comprehension of probability information and forecasts really matter? Does it affect the risk judgments that people make and or the protective actions that they think are appropriate in response to a given product, right? And so what we looked at here is the relationship between product comprehension, again down here on the bottom, where we simply looked at the number of products that someone was able to correctly interpret. And then we compared that to that person's risk, whether or not that person's risk perceptions were in alignment with what forecasters judged the risk to be based on the forecast, right? And then the same thing with protective action, right? And by and large, what we found is that people who correctly interpret products are significantly more likely to agree with expert assessments of risk and appropriate protective actions than people who incorrectly interpret products. And perhaps more alarmingly, what we found is that on average, people who incorrectly interpret products tend to underestimate risk and the protective actions necessary to ensure safety during a tropical cyclone event. Right, so conclusions. On average, we have found that members of the public and emergency managers are less numerate than forecasters, but that there is significant variation in all three groups. Numbers and probabilities are more or less intuitive for some people than others. And this is unfortunate because numeracy strongly impacts comprehension of forecast products that include probability information. And moreover, product comprehension goes on to strongly impact risk perception and the protective actions that people believe are appropriate in response to a given forecast product. In other words, we have generally found that emergency managers and members of the public have relatively low levels of numeracy in comparison to forecasters, which causes them to incorrectly interpret many of the products that we currently use. And that might have implications insofar as it affects their risk perceptions and the protective actions that they think are appropriate given the forecasts that they see. Right? So what does this all mean? Well, as we see it, this means one of three things. Right? These are our thoughts about how to move forward. Right? One thing is that we could abandon forecast products that include probability information. Right? People generally have low levels of numeracy, right? So why include numbers in forecasts at all? We think, as I say here, that this is a bad idea. There's really strong evidence in the social science community that uncertainty information and that probabilities help people make decisions. They even help people make decisions that have low levels of numeracy. And so we are opposed to the idea of abandoning forecast products that include probability information. The next option is that perhaps instead of abandoning these products, we can develop training materials and short help messages to help less numerate people make sense of forecast products that include probability information. This is something that we often see in the health risk community, where doctors work with patients that have relatively low levels of numeracy, make sure that they understand the risk of a given drug or the risk of a given treatment. And that help can range from a training session that requires 10 to 15 minutes of someone's time, all the way down to 1 or 2 sentences that you can add to a given graphic to help people with low numeracy better understand what that probability is communicating. Right? So those are the first 2 options. The third option is that we can abandon or reformulate some products and develop training materials and help messages for other products. In other words, we can abandon the products that don't seem to be working very well, or the products where there is very little hope for people with low levels of numeracy, and develop training materials and help messages for the products that seem to be working pretty well, and we think we can help people with low levels of numeracy make sense of those products. So next steps. So we think that option number 3 here, abandon and reformulate some products and develop training materials and help messages for others, is our recommendation about how to move forward. And so what we are doing right now as this project winds up is we are working to identify the products that may require reformulation, right? And we're going through this and doing this in a number of different ways. But one way that we're doing that is by looking at statistics and plots like you see over here on the right. What you see over here on the right is along the bottom, someone's weather numeracy and the probability that a person was able to correctly interpret a given product. And what you can see here, for example, with the wind speed probability graphic, you see a pretty strong linear relationship. People with low levels of numeracy, there's about a 1 in 4 chance that they get that correct, whereas people with highest levels of numeracy, there's a 3 in 4 chance that they get that correct. But you see that it's generally linear. And the same thing with respect to the potential storm surge flooding map. You see this relatively strong linear relationship. But when you get over here into the probabilistic quantitative precipitation forecast graphic, you see that as you go from these low levels of numeracy, 0, 1, 2, 3, 4, that doesn't seem to affect the probability that you correctly interpret that product at all. You don't see a marginal improvement in interpretation until you get to the highest levels of numeracy. And so effectively what that means to us is that this is an especially difficult product to interpret, and that people with low levels of numeracy almost have no hope of being able to interpret this one correctly. And so this potentially is a candidate for thinking about ways to improve the product to help people with these lower levels of numeracy make sense of the information that the product includes. So in addition to working to identify these products that may require reformulation, we're also developing training materials to improve weather numeracy and comprehension of forecast products that include probability information. We're actually right now in the midst of developing a set of experiments where we supplement probabilistic products with short help messages to see if we see an improvement in comprehension among folks with lower levels of numeracy. And then we're also, as I said, developing these help messages to help people with low numeracy make sense of these specific products. Our results are forthcoming here. We expect to have results of the impact of some of this training and some of these help messages in the next month. And so if you have any questions or if you're curious about whether or not we feel like there are some messages that can help better communicate some of these products, please stay in touch. And as I said at the beginning of the presentation, here is our contact information. You're certainly welcome to contact me. Jinan's on the call and happy to answer any questions that you have today, but also by email or any of our other collaborators here. And before I close, I just want to acknowledge that data analysis that I showed you here today was funded by the award that Gina talked about. But the data collection for this process was funded by the OU Office of the Vice President for Research. So we really appreciate support from both of those groups. And with that, I am going to open it up for questions.
Great, thank you so much. This was an excellent presentation. I learned something, but I'm going to start with our questions. We have several. So first up, I believe this was when you were on slide 6. There's a shocking difference in general numeracy between forecasters and the emergency managers' general public. Interesting that the double peak for forecasters. Any idea why the double peak is occurring?
I'm not sure. I think what we're observing is that you effectively have some forecasters that have, these especially high levels of numeracy. And then you have another group of forecasters who are clearly have higher levels of numeracy than emergency managers as a member of the public, but just not quite as high as some of those other forecasters. And we seem to observe that with respect to emergency managers as well, is that you effectively have these two groups. You have the emergency managers who look like members of the public, and then you have the emergency managers that have these moderate to middle levels of numeracy that are kind of on par with the lower level forecasters, if that makes any sense.
Great, thanks. And then I believe on slide 10, this question relates. Did your research investigate accessibility issues also possibly contributing to difficulty interpreting the products, such as color contrast, small font size, legibility, etc.?
No, we have not done this, but this is something that we're very interested in doing in the future. So part of what we're trying to do as we develop these help messages is call attention to some of the features of these products that folks with visual or color impairments or folks who aren't able to read legends, it might help point to some of those important pieces of information that they would have to pay attention to or recognize in order to correctly interpret the product. But that's an excellent question.
Great. Okay. So could you address the following potential issue? regarding interpretation of the existing products, some weather service employees and emergency managers likely have received training specifically on these products prior to responding. Does this complicate the results at all?
Yeah, I think it does. And so we actually ask emergency managers whether or not they have been through any training exercises to see if somehow those training exercises benefit their comprehension of the products. And we don't see a very strong effect. General numeracy and weather numeracy seems to have a much stronger effect on comprehension than does the training exercises that forecasters have been through or that emergency managers have been through. But that being said, we are working with some folks where the training exercises that we're developing are a little bit less focused on specific products and a little bit more focused on how to understand probability information in the context of the weather. So for example, we focus on things like exceedance probabilities or percentiles or the different formats that forecasters use to present probability information. And our hope is that by helping emergency managers and specialized members of the public better understand kind of the basics of probability information in the weather context, that we can generate a sort of higher weather numeracy among emergency managers, and that higher weather numeracy translates to better understanding of multiple projects rather than focusing our training on each individual product.
Great, thank you. Our next question. Have you looked at how people interpret percentiles versus probabilities themselves? The QPF is the only one presented as a percentile, which may explain why people have a harder time interpreting it.
Yes, and that is exactly right. So one of the questions that we ask in our weather numeracy scale asks someone to interpret a percentile, and what we see is that people are especially bad at interpreting percentiles. They're also not very good at interpreting exceedance probabilities. And so when you have a product that combines an exceedance probability with a percentile, it's not a huge surprise that comprehension of that product is fairly low. You see much higher levels of comprehension when you present information using unconditional percentages or natural frequencies like a 1 in 10 chance, that kind of thing.
Awesome. Okay, so we have a question from the Weather Program Office. Can you talk about the positives and negatives of using qualitative categorical descriptors in lieu of numbers to mitigate public numeracy skills? For example, risk categories in the Weather Forecast Office, hurricane threats and impacts graphics, or et cetera.
Yeah, that's a really good question, and something that we're actually focusing on both for this project and for some other projects that we're looking at. Our understanding or our suggestion is that it is most appropriate potentially to use numeric risk categories and or words in addition to probabilities when trying to communicate uncertainty. Because some people will latch on to the numbers and other people will latch on to the words. And so if you're able to present both of them, there's a greater chance that you will reach sort of that broader audience. Our only concern there is that sometimes there is ambiguity in the way that people interpret different words. For example, when you say that there is a moderate risk of something happening, for some people, a moderate risk might be a 10% chance. For other people, a moderate risk may be 50% chance, and yet for others, it might be 80 or 90% chance. And so we caution forecasters that if you are going to use those verbal descriptors or those word categories, that you try to also include numeric probabilities in some way to help orient people to, when you say moderate, do you mean sort of do you mean 50%? Do you mean a little bit lower than that, a little bit higher than that? And so this combined technique is what we are sort of advocating for both in this project and in others.
Great, thank you. Our questions are still growing, so I'm going to try and get through as many as possible. Since the National Hurricane Center has customers outside the US, have there been any studies of numeracy in those other countries, such as the Caribbean and Central America?
Not yet, but we are getting ready to launch a survey that is written in Spanish. And the intention there is to understand the numeric ability of U.S. residents who speak Spanish, to see how that compares to U.S. residents who speak English. And in the Spanish survey, we're hoping that part of that survey will be done in Puerto Rico, with an intention of understanding whether or not levels of numeracy in Puerto Rico are different or similar to levels of numeracy that we see in other places.
Great, thank you. Our next question, with the two groups of forecasters and emergency managers, did you collect any data about length of experience in the field, degree background, et cetera, that could be used to disaggregate the data and see if that leads to any correlations?
Yes, we did for both emergency managers and for weather forecast offices, our forecasters at WFOs. We did ask them how long they've been in the field, and we also asked them if they have a college degree, the field of their degree. We haven't had a chance to look at those data yet, but we are really excited to try to dive into the data a little bit to figure this out a little bit more. The other thing that we have data on, so it's important to remember that for emergency managers, some of them are full-time, others are part-time. Some of them are police chiefs or fire chiefs, and their job doesn't really revolve around the weather. It only revolves around the weather when it's necessary for it to. And so for those folks, it's quite possible that their levels of weather numeracy are quite a bit lower than the levels we observe among emergency managers whose full-time job it is to manage risks associated with emergencies and weather emergencies in particular.
Understood. Did you examine anything related to where a legend was placed upon a graphic?
Yeah, we haven't done anything like that, but I think that's a really important question. I'm going to slide over here to an example of the PQPF graphic, and I have a suspicion that what is going on for some people is that they don't really notice the legend being on the bottom left here, or it's not especially easy to read that legend. And so I think partly what is happening is that people with high levels of numeracy know how important it is to find and read the legend before they try to interpret a graphic. People with lower levels of numeracy, they might not sort of realize that all graphics are different, and therefore it's really important to find that legend. So my guess is, and I have no data to back this up, but my guess is that folks who have lower levels of numeracy are going to do especially bad at interpreting products if the legends aren't clear and obvious, because they don't have sort of the underlying motivation to try to look for those legends every time they encounter a new graphic.
Great, thank you. One of our listeners works directly with the Emergency Management Agency in Delaware, and he was saying that they twice asked the State Climate Office to provide them training on forecast products. This has worked really well, especially during severe weather events. Have you seen other states do something similar?
Yeah, I have seen some other states do something similar. The Hurricane Center also does a lot of training in concert with FEMA, trying to help emergency managers make sense of these products. And Robbie being on here, I'm sure that he can answer some of those questions if you have specifics about how that training works. But I got the opportunity to go to one of those trainings, and they did spend a little bit of time talking about the different products and how to interpret the probability information in those products. But I think that training is really essential, because as we can see here, that, absent training, we can get really different interpretations of what these products intend to communicate.
Speaking of training, does it seem possible to train general numeracy? Do training materials for numeracy exist in other disciplines? And what do those look like? Can you draw on those materials to help inform your training materials?
Yeah, that's such a great question. I have not really seen a lot of training materials developed to train general numeracy. And I think that is by and large because a lot of folks in the numeracy community, these are primarily psychologists, they understand numeracy to be something that's somewhat immutable. Like, it doesn't really change over time. After you've gone through your schooling and have reached your sort of formative periods as an adult, you have the levels of numeracy that you have. But what I have seen is that there are successful attempts to train numeracy within specific contexts, right? So rather than training someone to understand probability information generally across all aspects of life, we think it can be very fruitful to train people to understand probability information in the context of the weather, right? Because that places limits on the kind of information that someone needs to be a consumer of this kind of information. And so with our training materials, we're targeting weather numeracy a little bit more than we are targeting general numeracy. But it'll be really interesting to see in the future if we can develop other training materials on general numeracy to see how those kind of ultimately translate into people's ability to make sense of and interpret these products.
Great. I'm going to grab about 3 more questions. So our next question is, did you present the products in the survey in the same order, or did you randomize the order? And do you think that the change in framing within the products overall or within the survey may have contributed to this result?
That's a good question. So we did present the products in order, and it is possible that sort of quickly moving from one frame to the next does lead to some confusion in interpretation of a product. In the future, I think it might be interesting to try to randomize that to see if we notice any differences. But one of the things that's really interesting about this domain is that, at least with respect to tropical cyclone events, oftentimes you encounter kind of multiple products all at once, right? You might see a storm surge probability product, and then you scroll a little bit below on Twitter, then all of a sudden you see a QPF product. And so you really do have to be able to quickly switch from one to the other in order to be able to make sense of this different kinds of information. And as I said at the very beginning, these products use different strategies to communicate probability information, right? So the storm surge product talks about greater than 1 foot above ground of stormwater inundation, and it tells you a 1 in 10 chance that you would experience that, whereas you get almost the exact opposite of that with the PQPF product. They talk about the probability that it will not be exceeded. So it's on the left hand, on the left side of that point in the probability distribution. And so it really does require you to quickly flip from one way of thinking to another way of thinking if you want to meaningfully understand these products.
Thank you. Our next question, will your research continue to be survey-based, or do you intend to conduct in-person or remote interviews to follow up on the survey results? For example, performing usability tests.
We really hope to sort of move to the usability test, and in particular, as we start to develop training exercises. As I said before, we kind of have two strategies towards helping people with low numeracy understand these products better. The first strategy is to develop these relatively quick help messages, almost that forecasters could put on Twitter or on Facebook when they're talking about a given product. The other strategy is to develop these kind of longer trainings that would help kind of a higher level population make sense of these products. And in order to develop those trainings and better understand how to calibrate those trainings to maximize weather numeracy and interpretation of these products, I think it is going to require more intense interaction and user studies to make sure that the things that we're actually training, that people understand what it is that we're talking about, and to what extent that does or does not translate then into these levels of numeracy or these product interpretations that we hope they will translate to. And so as we develop those trainings, I do think it will be necessary for us to go beyond survey research and actually sit down and physically interact with emergency managers and others to make sure that our trainings are effective.
Does that mean general numeracy we should spend more time teaching our forecasters or training our forecasters on general numeracy?
My response is yes. I do think that, as I said before, there is variation in numeracy among forecasters, and I think it is important that as we move towards the development and use of probability information and forecasts and products, that we spend more time training forecasters how to effectively understand this information and how to help communicate that information to emergency managers and the public. So yes, I think forecaster training both on general numeracy and weather numeracy it is going to be important in the future.
Great. Two more questions. One of them is a behind the scenes questions. Wondering if the comprehension of the PQPF product was lower because it looks pretty much the same as the regular QPF products from the Weather Prediction Center that people are probably more familiar with.
Yes, I think Robbie, I think that's your question. I think you're exactly right. And I think that's why you see, like, for example, this plot on my page, that when a emergency manager sees this, emergency managers are most familiar with the QPF product. And so when they see this, they think that this means that this area is going to get about 4 inches of rain. And that's why 52% of them said that, instead of interpreting it in the probabilistic way that it was intended. And so I think definitely, as we think about product redesign, making sure that there are ways to signal that this is a probabilistic product rather than the deterministic QPF product is going to be important for decision makers.
Speaking of that, when you show the storm surge products, they were better understood, but they contain exceedance values that are hard to perceive. How do you rationalize that?
First off, I should say that I think it's not a coincidence that the storm surge product is best understood. I think that the reason that the storm surge product is best understood is because it was developed in closest connection with social scientists. Of the three products that I'm talking about today, my understanding is that this one had the most input from social scientists and end users from its very inception. So many, if not all, of the decisions that were made about how to effectively communicate the risk of storm surge were made in concert with emergency managers and end users who are going to be responsible for interpreting this information. And so I think that that's partly what we're seeing here, especially that's why you see these high levels of comprehension among emergency managers. There are slightly lower levels of comprehension among members of the public, and that's partly because you really can't consult every member of the public when developing a product like this. And on top of that, that 49% likely reflects the fact that people don't really pay attention to the difference between an exceedance value, or the difference between sort of a percentile value, which would tell you whether or not you would expect to get, more of this or less than this. And I think that's partly what we're seeing here.
Awesome. Thank you so much. Okay, last question. Will you have a paper or public report with recommendations for products and help sections to encourage best practices for communications from forecasters and scientists in general?
Yeah, so we're working on an academic paper that will kind of talk about the implications of weather numeracy, in particular on how people interpret products, and then how that interpretation goes on to affect risk perceptions and protective actions. But we're also going to have a policy report that would be directed more towards the people we hope will use this information to update risk communication practices. And so we'll have recommendations at the end of the day, hopefully tangible recommendations. Here's what we think we need to do moving forward. Unfortunately, we only focus on 3 products in this research. We only look at storm surge, wind speeds, and precipitation. But there are many, many other probabilistic products that folks in the Weather Service use, including in the TC domain, but also in the winter weather and severe weather domains. And so we hope that this work also establishes a template for helping us to evaluate some of those other products. And so, yes, we'll have recommendations at the end, and we really welcome feedback on the extent to which forecasters and emergency managers can use those recommendations when trying to better communicate the information in these products.
Awesome. Thank you so much. This has been an excellent Q&A, and I want to thank everyone for attending today. Our next presentation in this series will be by Dr. Julie Dumoth and Robert Presley from the National Center for Atmospheric Research. It will be on understanding how members of the U.S. public access, share, and interpret changing forecast information, tropical cyclone threats. So please be on the lookout for those emails to your NOAA email addresses from the library. Reminder, we did record this, so if you had to hop out early and missed a section, or if you want to share this with a colleague, please visit our YouTube channel, which I did post in the chat earlier. And I have not asked all the questions we got. There are a few more, but they will be passed on to our speakers today, and they can reach out to you offline to answer those questions. Thank you all so much for joining us, and I hope you have a wonderful and safe rest of your Wednesday.